Right, in the name of the Cosmos Creator. Hello, my name is Armin Takbiri from Iran, and today I want to talk about a problem as O-IYPT 2020 problem set, so memory filter. This problem says that a heavy particle may pass through the soft film. However, a light particle may remain on the surface. And this problem asks us to investigate the properties of such a memory filter. The phenomenon is a heavy particle may pass through the soft film and a light particle may remain on the surface. And this problem asks us to investigate the properties of such a memory filter. At first, I want to talk about the introduction of this phenomenon, which here I want to go through the my initial observation and my literature review. Based on my evidence, particles may remain or pass through the soft film. As you observed here, in this occasion, particles remain on the surface, and after that, soft film shows harmonic motion. And at the end, soft film will rupture out. And second one, as you observed here, particles pass through the soft film, and after that, soft film shows harmonic motion. These are the two literatures with investigation of these two are really close to this phenomenon. First one published in 2017, and it investigated droplets, and that's not related to this phenomenon, but it has a really good control system. And second one published in 2018, and it investigated particles, but it has a manual system. Here we want to repair these cons and investigate something else. In the qualitative viewing, I want to go through the analyzing conditions and purpose of rupturing. At first of all, as I mentioned, particles may pass through or return to the surface. And before that, we have to recommend some parameters of these apparatus. For a particle, we have potential energy. And for surface, we have surface energy. And here, based on energy conservation, we could deduce that potential energy is about kinetic energy at impact moments. And here, particle will pass through the soft film on condition that kinetic energy of the particle is more than the surface energy of the soft film, and because of this, soft film cannot remain particle on the surface. As particle will remain on the surface on condition that surface energy of the soft film is more than the kinetic energy of the particle. As I mentioned before, after retention, soft film will rupture out, and here I want to investigate why soft film ruptures. Before that, we have to recommend something. Soft film can go down until the maximum length, and after that, soft film will rupture out. And this phenomenon, soft film will rupture out because particle will go down until the maximum length, and after that, soft film will rupture out. In a mathematical, I return to analyzing system and define some energy ratios, and I want to investigate the ratios versus conditions. As you know, we have a lot of ways for analyzing system, and one of them is defining some ratios, which are usable in fluid mechanics. And we have another way. And I rather to use this way because in this apparatus, we want to work with a fluid, and our fluid is memory filter. In this way, we have to you have to define energy in a ratio which include all parameters. Before that, we have to define all parameters. For particle, we have bit radius, mass, and kinetic energy. And for surface, we have filter radius, surface tension, and surface radius. And here we said that the condition of particle is a function of these two energy. Why? Because kinetic energy is a function of mass and altitude of the particle, and surface energy is a function of bit radius, filter radius, and surface tension. Therefore, these two include all parameters. And here we divide our ratio, which is equals to the dividement of these two energy, where kinetic energy equals to half of mv squared, and surface energy equals to gamma multiply c, where c is a geometry term. And in this equation below, phi equals to 2 inverse hyperbolic cosine of bit filter radius divided by bit radius. And based on these two, we could deduce E star and E equals to these rates, where in this equation, we include all parameters. As I mentioned before, particles may pass through or return to surface. And here we want to investigate some intervals for our parameter, I mean E star, and based on this, we could deduce our conditions. Before that, we have to recommend the relation between these two energies. If surface energy is less than kinetic energy, particle will pass through, and if it's more than kinetic energy, particle will be retained, and if it's equal to surface energy, it's something between passing through and retention. And here, I use this provement for all these conditions, and I deduce the intervals. If surface energy is less than kinetic energy, we could deduce that E star is less than 1, and after that, logarithm of E star is less than 0. And it is proven for all conditions. And if I want to conclude this part, if logarithm of E star is less than 0, particle will pass through the soft film, and if it's more than 0, particle will retain, and if it's equals to 0, it's something between passing through and retention. In my experiments, I want to talk about my control system and my apparatus. And then I'll talk about my parameters and my measuring tools. Here, That's an ordinary format of my apparatus, which in this apparatus, I've been prepared a control system for controlling some parameters that I will tell you, and the altitude changer. And based on filter fixer, we can fix this filter and in the same place. Okay, before I want to talk about my control system, we have to talk about some parameters that need control, which there are cross-section of particle and placement of the particle. Cross-section is so important because by changing the cross-section, bead radius will be changed, and after that, geometry term will be changed, and surface energy will be changed as well. And here, placement is so important because thickness of the soap film in each place is not equal to each other. And here, that's the ordinary format of my apparatus, which red points the particle, and orange points the relative point. And the distance between head of blade and relative point, we name it as length, is at experimental measure, and it starts from 3.8 up to 4.5 centimeters. And here's, by rotating the blade, the particle will fall. And if I want to take it closer to this, as you observed here, by turning on our control system, particle will fall to the soap film. Okay, for a bead, I define 4 types of bead here with different geometries and with different masses. And as you can see here, I didn't choose this on purpose because I want to investigate the geometry and the mass of these particles. For soap film, I defined 4 types of soap film with the same material but with different radiuses, which the last one, it doesn't work because you cannot prepare a stable soap film. And for the soap solution, based on changing the glycerin percentage, we can change the surface tension. And we measure the surface tension of this solution with tensiometer. For altitude, I've defined 3 types of altitude here. We've signed it here on the altitude changer, and after that, we change it. Okay, before that, we have to talk about some parameters that need specifically measurement tools, which there are impact velocity of particle, mass, and radius of particle. For measuring the impact velocity, I use tracker, and based on tracker, we can measure the impact velocity at impact moment. But how? As you know, V equals to derivative of x with respect to t. And delta x between 2 frames equals to 1 divided by frame rate. And as you observe here, in this case, that's a really low variable. And we could deduce that in this low variable, V equals to delta x divided by delta t. And then based on this equation, we could measure the impact velocity. And for the mass and radius of particle, at first we define our particle in some groups here, and based on calibration group, we've chosen some particles which are in the same radius with the calibration particle, and we measure it here, measure the mass, and we can measure the average mass from each group, and we get average from this group, and where A is the number of groups, and show us the more group, the less error. In my experiment, as you observed here, these are my experimental results here, and this is for seed shell and this is for resin sphere. And level of ESR is based on 10 power minus 1, and kinetic energy and surface energy is based on microjoule. And here, later, I will talk about the condition with our prediction. And for our prediction, I use MATLAB, and based on the equation that we have, we can predict the condition of these particles. And here, these are my MATLAB results, and as you observed here, in the same surface energy, if kinetic energy of the particle is less than 21, the particle will be retained, and if it's more than this variable, the particle will pass through. And as you observed here, in this case, particle all pass through the soap film and is more than 21 microjoule. Therefore, our experimental results are true. And here for the seed shell, as you observed here, based on color bar that we have here, if kinetic energy of the particle is less than 26 microjoule, it will retain, and if it's more than this variable, it will pass through. And as you observed here, all of these conditions shows pass retention, and these show us that our experimental results are fit. And for the seed shell, as you observed here, if kinetic energy of the particle is less than 3 microjoule, it will pass through, and if it's more than this variable, it will retain. And here, as you observed, all of these conditions show us that particle pass through the soap film, and show us our experimental results are true. And for Oregon, as you observed here, if it's more than 32 microjoule, it will retain, and if it's less than this variable, it will pass through. And here, as you can see, from these 2 points, it shows us the error. and it must be passing through, but it will retention. Here I said that it's happened because of wasted energy. We said that in organs the wasted energy is really high, and because of this, these error causes. And the group definition will have some errors, and in the control system error we have. It might be because of the control system. If I want to conclude my presentation, at first I talk about At first I talk about why solving the rupture and the conditions I've investigated, and then I talk about our parameter, I mean E star, and after that I talk about my apparatus and my parameter, and at the end I talk about my experimental results versus my MATLAB results. Thank you.